Good afternoon, all of you, all the students. So, I, Professor Vivek Joshi, SSIP Coordinator, ING Patel Institute of Technology, welcomes you all. So, today we have scheduled a webinar for SolidWorks, and we have very eminent expert, Mr. Gaurav Harane. Sir is here with us. And also in a panel member, we have Dr. K.B. Rathod, sir, and Professor Nirav Rathod, sir. Dr. K.B. Rathod, sir, is a head of Mechanical Engineering Department of RNG Patel Institute of Technology. Rathod, sir, has completed his PhD from SVNIT, Surat, and sir has a very vast and wide academic experience in the field of teaching. So I welcome you, Gaurav sir, Nirav sir, and Rathod sir. Now I hand over Rathod sir to start the session and give some glimpse and some information about this session. Please, KB Rathod sir.
થેન્ક યુ પ્રોફેસર વિસી જોશી. ખાસ મારે એ કહેવાનું છે કે આપણે જે ઓનલાઈન વેબિનારનું આયોજન કરેલું છે જેમાં આજે આપણે મેકેનિકલ વિભાગનું સૌથી પહેલો વેબિનાર શરૂ કરવા જઈ રહ્યા છે અને આ વેબિનારનું આયોજન અમારા ડિપાર્ટમેન્ટના પ્રોફેસર નીરવબી રાઠોડ દ્વારા હાથ ધરાયું છે અને તેમને જે એક્સપર્ટને બોલાવેલા છે તે આપણી સાથે મોજૂદ છે, જેમનું નામ છે ગૌરવ હરાને, અને એ આપણને સોલિડવર્ક્સ મોડેલિંગ વિશે આપણને બધી માહિતી રજૂ કરશે અને આપણને એના વિશે જ્ઞાન આપશે. તો આ સેશન દરમિયાન આવા 3 સેશન કરવા જઈ રહ્યા છે, જેમાં અમારી સાથે હંમેશા સ્ટ્રીમિંગ કરવા માટે મોડરેટર તરીકે પ્રોફેસર વિસી જોશી અમને સાથ સહકાર આપશે. તો હું સૌથી પહેલા એમને થેન્ક યુ કહીશ અને પ્રોફેસર નીરવબી રાઠોડને કહીશ કે જે આપણા મેન વ્યાખ્યાતા છે જે શ્રી ગૌતમ હરાને સાહેબ, એના વિશે થોડું આપણને માહિતગાર કરે અને ત્યાર પછી આપણે સેશનની શરૂઆત કરીએ. ઓવર ટુ નીરવબી રાઠોડ.
Good afternoon, all the viewers. I am Nirav Rathod, Assistant Professor, Mechanical Engineering Department, RNG Patel Institute of Technology. Welcomes you all for the webinar on SolidWorks Solutions for Design to Manufacturing. Let me introduce our today's guest come expert, Mr. Gaurav Harane sir. Gaurav sir is currently working as an application engineer in one of the known industry, that is Engineering Technique, Vadodara. Sir has qualified professional training course, that is Six Sigma Green Belt. Sir has wide experience in simulation, mold flow simulation, HVAC management system, and cost and control. Sir is SolidWorks trainer and has trained more than 50 plus professionals for the SolidWorks. Sir has published 3 research papers in the journal. Now, in today's competitive market, industries need to produce their products in the faster rate, with the minimum cost, and with high and predictable quality. Now, to achieve this, industries are looking forward to use the SolidWorks to streamline their working flows. Thereby, they can achieve their target with the minimum effort. So I request Mr. Gaurav Harane sir to please start the session. Sir will take some live case study, and thereby he will explain how SolidWorks is used in industries. So over to you, Gaurav sir. Thank you.
Yes. So okay, so is my screen visible to everybody?
Yes sir, visible.
Yes.
Yeah. So thank you very much for inviting me to this web series of online webinars. And let me begin the today's webinar, that is SolidWorks, solution for design to manufacturing. So what does design to manufacturing means? So SolidWorks software is having all the capabilities starting from scratch, that is from the initial stage of 2D drawing, from project concept to the final stage of manufacture, right? So in between, everything will be covered in today's agenda, right?
So what is SolidWorks? So SolidWorks, as we all know, is a very renowned software for 3D CAD modeling. Also, it is having electrical 3D, electrical 2D, PCB. Then for validation, it is having simulation, flow simulation, plastics, etc. So it is a bundle of all the different modules which are available. Then we are having manage. To manage all the 3D files, 2D drawings, we have this manage tool. Then collaborate, that is visualize e-drawing for creating high quality rendered images. And finally build, that is if you want to inspect any 2D drawing, if you want to create any good marketing reports, right? So composer, etc. So there are various I can say modules which are available in SolidWorks. So in today's webinar, I would be covering few of them, like the 3D CAD modeling. I will start with 3D CAD. Then we will go into the importance of validation, in which I will practical case studies which I have done with some of the customers. You will get a good knowledge of it, right? And so on. So, SolidWorks 3D CAD. So the power you need to drive innovation. It is a 3D mechanical CAD software. Parametric feature history based modeler. What does this parametric means? I hope all of you have used SolidWorks, right? In your college. So the 3D CAD software is very user friendly. So besides 3D CAD, part modeling, 2D modeling, assembly modeling, it is also having with it industry specific tools like sheet metal, weldment, mold design, surfacing, etc., which are used for industry specific tools. If a company deals with sheet metal industries, so apart from part assembly drawing, it uses sheet metal or weldment. If it is in mold industry, core cavity, then it is used mold design, etc. So let us move forward. I will just showcase you few of the great functionalities of 3D CAD. So this is a simple model of a miter saw, which is used for cutting of pipes. I will jump on to SolidWorks. Yeah. So this is the model. So it is made up of various sub-assemblies and various parts, right? And let me showcase to you few of the movements which are created, like table rotation. So you can create such kind of movements also, which are called configurations. Like if you want to showcase how this table is going to move, right? Or you want to show how the bevel adjustment is working, the head motion, etc. Right? So these are called configurations which can be done. Now let me just quickly highlight you the important part in this whole assembly is this yoke part, which I have highlighted, which is connecting this bevel adjustment to this cutter, right? So this is the part which I have chosen, in which I will showcase you how quickly we can create such designs, right? We all know we can do part extrude cut, we can draw sketches. So I will not cover those conventional method of modeling. I will use few of the great techniques or shortcuts by which you can create your part modeling in a faster way, right? So SolidWorks starts with part assembly and drawing. So I will go to the part and select the plane on which I want to start the sketching. All right. Now let me go and use these 2D entities. As we all know, SolidWorks is having all the types of 2D entities starting from circle, rectangle, square, polygon, etc. Right? So I will start by creating a center line. Then I will provide the dimensions to it. Also, SolidWorks is having a great tool to give dimensions and give dimensions which are fully defined. Now, most of the cases, what happens when you try to create a sketch, you sometimes forget to fully define it. Fully define means you forget to give certain dimensions to it. That's why it belongs in underdefined criteria, like this blue color. I have not given radius to the circle, so it is blue in color, right? So whenever you do any of your modeling, it is important to give the perfect dimensions so that it is fully defined and no other dimensions are missing to it, right? And there are like list of relations which are available. So if you select any entities, like I have selected two circles, and you can provide the relations to it, like the equal relations what I have provided. Now moving on further, I'll create one more entity and complete my 2D sketch. So you can also see at the bottom, there is an underdefined option is popped up. That means all the dimensions are not provided to it. Okay, see, the rectangle has turned black in color. That means it is fully defined. But still, the circle is not fully defined. It is blue in color. So I will just give one more dimension. Yeah, this is 40. Now it is completely defined and it has turned black in color. So this is one of the things which many of the designers miss. They actually know, but they miss how to give fully defined dimension scheme. Now once I exit it, I will be into my 3D environment, and with the instant 3D command, what I have highlighted right now, you can directly convert this into 3D. No need to go into the feature, right? Like extrude base, revolve, etc. Okay. Now let me again create one more sketch on this face. So this is very intuitive tool, right? Many of you have used this. You have found out very easy. So I am creating one more sketch in this. I am creating two circles, right? And I want to dimension this. Again, there is one more shortcut. You can use fully defined sketch option to give all the dimensions automatically. No need to provide each and every dimension individually, right? You can edit them if required, right? So if you use the option of fully defined sketch, all the dimensions will be automatically given. So there is no need to find out which dimension is missing to completely define it. Okay, now moving on forward, once you exit the sketch, we have the option of contour select tool, in which you can add material to different contours. Like I want to add the material to this contour, or for example, I'll add to this contour right now. You can drag it to either direction, right? For example, I will drag this to 30, and I want to again drag this one. For example, I will drag this to 40, and I want to make it hollow. So if you drag this in this direction, it will add material. And if you drag it in the other direction, it will automatically define that extrude cut is to be used. Right? Isn't it a great tool? So I have not even touched any of the commands at the top of the features. And I've created this within 2 minutes. And finally, I'll use few more commands and complete the 3D modeling. Like I want to make it a mirror. So I'll select the plane, select the body, and say OK. Now, there are various sharp corners. So we all know we use fillet to remove the sharp corners, right? So whenever you click on one of the edge, the option will pop up in which edges you want to apply the fillet. So again, there is no need to select each and every edge individually. So with the fillet expert command, SolidWorks will automatically showcase you where you want to apply fillet, and likewise you can apply the fillets, right? Let me select one more and I will finalize the model. Like I want to apply fillets over here, and you can give the values. Also, one of the good thing is you can use copy paste command. So we all are aware of the Control-C, Control-V option, right? We use in our Word, Excel, PowerPoint, etc. while creating reports. So same way, you can even use this over here. So just by dragging one fillet from location to another location, right? So these are few of the good shortcuts what you can use to design your products in a faster way, right? So I have used copy paste command over here, but if you want to cut paste any fillet, so you can also do that thing. So if you press Control and drag it, it will be copy paste, and if you directly drag it, then it will be the other one, cut paste, right? So these are few of the things which are really important, the shortcuts while you design your model, right? So once your model is ready, we can go ahead with the drawing part, the 2D sketching, right? So for that also we have a good set of shortcuts available. So let me go on to drawing part, or else you can also open it from this option, make drawing. So let me just save it somewhere. I'll say desktop and save. So these are few of the tips and tricks what you can make use. So let me again move forward with the drawing part. So I am just creating the different views, and this is my isometric view, right? Let me change the display of isometric view and hit OK. Now drawing, 2D drawing is the language of engineers, right? So they will be understanding everything from this 2D drawing. So all the dimensions are required whenever you create any drawing. So we all know smart dimension option is available, in which you can just pick any of the edge and dimensions will be provided, right? Again, sometimes it is a tedious process to apply all the dimensions every time. With the help of model item diagrams, model items, you can just select the view and all the dimensions will be popped up automatically. Again, a very time-saving technique, and you can arrange them automatically, right? So again, if few of the dimensions you want to drag here and there, delete it, you can make use of it, right? So these are few of the good techniques by which you can create a drawing in a much faster way possible. Also, if we talk about assembly now, I will just cancel this. Yes. So if we talk about the assembly drawing now, okay, so let me open the assembly drawing for this over here. So bill of material is also automatically created in this. Yes, and balloonings also can be done automatically. But what I want to explain you right now is you can create how you can create the Excel file of the bill of material, in which you can also incorporate the images of the parts with the option of thumbnails, right? So once you save this file, you can even create bill of material in Excel, keeping in mind the images are also coming up, so that whenever this bill of material is forwarded to the concerned department, they can quickly see the preview, what they are actually going to buy the product, right? So without further any time wasting, I'll go on to the next part. So this was very basics of part modeling, right? What we have seen, what shortcuts, and let me go on to the next part. Yes. Now simulation. So how you can make use of simulation in your part modeling or the projects what you might be doing, how simulation will help you once you have created your 3D drawing, right? So I have just given you the glimpses of 3D, as all of you are knowing the basics of 3D modeling and all the things. So I will cover in this session few of the advanced topics like simulation in a little bit wider perspective. Now, all FEA, you all might be aware of finite element analysis. FEA is a very common term. You might have studied in your final year or maybe third year, right? If not in third year, in final year, you will be studying it. So what is the impact of simulation? Why we do simulation? To improve the product quality, to produce a reliable product, to filter out the weaknesses. Like if any of the model is failing, how will you come to know once you design it? You will come to know only by doing the analysis or by actually doing the practical testing of the part. Now, many of the times practical testing is costlier to have the whole setup and everything ready. So we rely on simulation softwares like to filter out the weakness in design. Then you can also predict sufficient product life. How many months, years the product will withstand, what is its life, right? So these are all few of the impacts on quality. And what is the impact on time? So we all know the general design procedure which is followed in most of the industry is shown at the bottom. We have the project concept, the idea is in our mind, then we do the designing part, right? We create the models, 3D models, 2D drawings, etc. Then what is done? Testing is done. Means the part is tested in the physical environment. Physical testing is done. And once the part is tested completely, we manufacture and deliver, right? So I hope there is no doubt in this cycle. So what can be done to reduce this cycle? Right? So that thing we'll discuss in this slide. So to reduce the project length, you can quickly check multiple designs. You can design n number of products, right? And quickly simulate it, check it, right? So there is no need to manufacture the same product with different design every time and then test it. Then earlier detection of potential issues. In design stage itself, if there are any issues like the thickness is less, right, or the rib is of less thickness, then you will come to know in the design stage itself. So you can reduce the potential issues which will be coming after the manufacturing is done. Trial error process can be reduced. Hand calculation will be reduced. So hand calculation, if we talk, so you all have studied strength of mechanics, some subject, right? In that you might have calculated with the help of various formulas, the cantilever beam or simply supported beam, right? When it will break and so on. But it is suitable or feasible for simple products. But if the product is much more complicated, like this gear, what we are seeing here, then how you will do with the help of hand calculation? It is difficult and it will take much more time. So you will reduce this time in hand calculation, which will finally help in your reduction in project length. So what we are doing with the help of software, design and testing, design and validation is combined, and the product which you comes out of the software is manufactured and it is right. There will be no any more potential issues or any problems in your product, right? So let us move forward. Cost. We have seen there are various project costs are occurring. Outsourcing cost, material can be cut if you use this validation part. So with the help of optimization tool, you can cut material cost, prototyping cost, etc., which will finally increase the quality and performance, reduce the time, and reduce the cost. So I have just given you the general idea how simulation will impact in the designing process. Now let me go on to the next, or we can say the first case study. Now this is actually one of the practical example, and I've chosen a very good example so that you can also understand and relate. So this is one of the part which we see every day. So I'll do the analysis of the crank, the cycle crank. Now these are few of the failures which are coming up in the crank, right? Because of the repetitive use, or maybe because of the prolonged use, the cranks would fail like this. Now we have to design the crank in such a way that it will withstand certain period of time, or we can say certain period of years, for example 5 years or 10 years, right? It should not be like you manufacture a crank and within a year it fails. It should withstand few number of years, like 5 or 10 years. So we have to again suggest the customer who is going to buy the bicycle to provide them the preventive maintenance book, in which we say that this part will have to be given maintenance after 5 years, 10 years, or few weeks, or maybe etc. So how this is found out? How the we can say that this part will last 1 year or 2 years or 5 years, right? So we will check that out. Many systems generate repeated or variable loading, right? Like the bicycle crank, there is a repetitive loading. Once you rotate the pedal, it will be loading, unloading, loading. So there is repetitive loading, vibrations are there, right? So these are few of the loadings which are coming up on the product, which may result in the failure. Now building a great product is very hard. Like 46% of new product launches sometimes fail. 75% don't meet life goals. Then 2 years is the average lifespan of successful product. So these are few of the points which I would like to showcase you. 85% of structural failure occur through fatigue mechanism. Now what is fatigue? You have studied in your engineering, right? So fatigue occurs because of the repetitive loading, and there are stages of fatigue. The first stage is the crack initiation. Because of repetitive loading, the component fails because of fatigue. And how you will come to know the fatigue? It will show some signs like crack initiation, then crack is grown, and finally the failure is done. Right? So these are few of the images what I have taken from the components to show you the fatigue, failure. And the cycle crank, the first case study what we will be studying. So we will make use of fatigue analysis also to check how this design is suitable or not, and for how many years of life it will withstand. Now, this is very common thing, like design scenario of a pedal. The average cyclist makes 5 trips per week. Will take an average, right? Spending just under 2 hours on their bicycle. And for example, he's covering 25 kilometers in 5 trips. So I've taken a general scenario. So for 1 year, it is 1440 kilometer. And the standard wheel diameter is 560 mm. So I have calculated the bicycle can move forward in 1.76 meter. So this is just a simple mathematics. So if we could design the crank to last 7 million cycles, means 70 lakh cycles, 70 lakh times loading and unloading is my objective. The cyclist can travel 12,315 kilometers. The average, we can say, life of the crank, of the pedal. So we could issue 8.5 years warranty to cyclist by this estimation, right? So this is how we estimate the product life, how it is going to be used. Now we will make use of SolidWorks to design this. So we have to find out which crank is better, which pedal is better. I am having 3 designs with me. Design 1, design 2 and design 3. And the inputs, that it must last 7 million cycle, and the pedal loading, the load which is going to come is 133 kg. Now I am using worst case scenario. We all know 133 kg will not come on one pedal at a time, but still we have to consider for worst loading scenario. What if all the weight comes on one pedal, right? So we never do the design or analysis considering the actual condition. So let us move ahead. So this is my pedal. This is how it is going to be function. So no doubt about it. What I have done over here, I have done the model simplification. Right, so I have removed all the chain and sprocket mechanism and I have simplified it for analysis purpose. So let me move ahead in software to check how you can make use of this software. Okay, so first let me showcase you how the modeling is done. So this is my crank design. So this highlighted, this is pedal, and these are my sprocket mechanism, which are all assembled, right? And we have various add-ins over here. You all are aware of the assembly module, and there are add-ins which are available at the top. Like if you want to do simulation, you can click on simulation and simulation functionalities will be activated, and the same for flow simulation. So what I have done, I have simplified the design. I have removed the chain and all the gears which are not required. And I am having with me 3 designs. First, then second, and third. So I want to check which design is suitable and fulfilling my criteria of 7 million cycles, right? So let me start with the first design. So whenever you create a new study, you have various options like static, frequency, topology, and some advanced studies like fatigue, non-linear, etc. Right? So you can select the study accordingly. Okay. So this is my study. So the first thing what you do, you will apply the material. So SolidWorks is having this material library inbuilt. So those of you who have worked on SolidWorks would have known this material library is inbuilt available with all the steels and all the materials available. Once the material is given, we apply the fixture from where it will be fixed, right? Like the fixtures are applied in all these holes. Okay, and force is applied over here. The force is applied in the downward direction, right? 1350 newtons. And finally, once we run the study, you will get the results. You will come to know what is the maximum stress. It is 215 MPa, right? And if it is failing or not, how you will check? So at the bottom, you will get to know the yield strength of the material, which is 275. So it is less than 275. The maximum stress means it is safe. Similarly, you will get displacement results. The displacement is coming 4.28 mm. Also, you can have the animation of it. In which direction the displacement is coming. And factor of safety. In my case, I'm getting 1.28 FOS. Again, factor of safety, it is just a factor, right? So what does factor of safety tell you? So if you increase the load by this factor, your component will not fail. But If you increase the load by more than this factor, then it will fail. So this is what safety factor gives us idea. Now let me move on forward to do the fatigue analysis on the same part. I want to know whether how much years or how much number of cycles this product can withstand. So whenever you do fatigue analysis, you will have to give the SN curve, that is stress versus number of cycle curves, right? Number of cycles versus stress. So as number of cycles are increasing, the stress is reducing. So this cycle is very much important. And then you will get the product life. So what is the product life that you are getting? It is 3.9 million, right? 3958885 number of cycles. So these are the things what I got from the first design, that the minimum durability cycle is this. The stress is 215. The minimum factor of safety is 1.28, and maximum deflection what I got is 4.2, right? So what does this SolidWorks flow simulation also helps you to quickly check multiple designs. I will jump on to the next configuration now, and with the same set of boundary condition, I will find out the results. Only design is changed. Rest everything is same. The stress, displacement, and factor of safety, right? So these are the results of my second. And let me again highlight you what is the fatigue or number of, what is the life of the product you are getting. It is 13 million cycles. So it is more than what we have in input, that is 7 million cycle. So I think this product is safe, and the previous product was having 3 million cycle, which was not satisfying our criteria. So quickly you can do multiple design checks, right? And finally, I will go on to the final design. So in this design, there is a small change. There is a bend given over here. Slight small bend is given, right? And these are the results. The stress is 248 MPa. The displacement is 1.8, and the efforts. And if we have a look at the fatigue study, the life is only 1.3 million cycles, which is very, very less. So what I have done with these three designs, I have taken into consideration, and I came to know that the second design is fulfilling my criteria of 7 million cycles. So second design, we can go ahead and go for manufacturing, right? So this is the benefit of validation. You can quickly check multiple designs if you have, and then come to a conclusion that which is the best design you can go ahead with. Now structure, material, and stiffness. So there are a few of the conventional manufacturing process like milling, turning, grinding, etc. So how to manufacture the product. And there are some of the advanced manufacturing process like 3D printing, in which we manufacture the product not by cutting the product, but by adding the material to it, right? Subtractive and additive manufacturing process. So these are the two basic manufacturing process. Now subtractive and additive. So I have just shown you how these differ from one another. Subtractive manufacturing, size optimization, shape optimization can be done. And with additive manufacturing, you can do the topology optimization. You can cut the holes or change the shape which are not standards, right? So the same thing if you use. So if structure, material and stiffness is less, so less energy is required, less electricity is required. So everything will be less. So if your part is light in weight, if you create an optimized part, then the energy, electricity and everything is less. So simultaneously, finally, the cost will be less if your product is optimized one, right? So these are the thing. So if all those increases, finally the cost will increase. And if all this will be less, the cost will be less. So you have to produce optimized product. Now this is a very important thing with respect to the material cost. Weight matters. For F1 motorsport, the value of weight saving dollars per kg is more than 1,20,000 because those are very fast and very light in weight. And like all the values are given for spacecraft, aircraft, automotive, and last is the factory equipment which are stationary, like any machine, lathe machine, milling machine. So it is $6 per kg. We are not using much more optimization or anything in such kind of machines. So we all know why F1 motorsport is one of the most costliest motorsport because of all these considerations. Right. So structural optimization I am going to discuss. So you can find the best alternative, reduce the time to market, reduce cost, weight, remain competitive, and improve the product. Now we have one more module of optimization in SolidWorks, right? Shape optimization or topology optimization. So if you recall the crank, second design was the final design what you have proposed, right? Now we can do more weight reduction in this by performing the topology optimization. So let me just activate yes. So what I have done, I have reduced the mass, keeping in mind that the part will not fail. Or else what is the use of mass reduction if it fails, right? So you can give here different goals like reduce the mass by 30% or how many percentage you want to reduce the mass, right? So all these things you can keep in mind. So the current mass before reduction was 0.4 kg and after 30% reduction it is 0.28 kg. So let me just highlight you. Yes. So by changing this slider, you will come to know how much mass you can remove. Now, if I change my slider to the light, it will remove more mass. Also, it is telling you few points like which regions you must keep and which regions from which you can remove the material, right? What we have done, the initial weight was 402.86 grams and I have made it to 303.36 grams, which is 25% mass reduction. So you can reduce the mass also by taking the help from topology optimization, which is inbuilt. Okay. So what are the benefits? Again, I'm repeating the same things. Remain competitive, reduce the weight, reduce the time to market, improve the product quality, etc. So these are few of the examples where structural optimization is used majorly. So mass optimization saves money without compromising the quality. Now let us go ahead to the next module, which is CFD, flow simulation. Right? So what we have checked until now, 3D CAD modeling, structural analysis, fatigue analysis, and topology optimization to change the shape of the product. So the next module is flow simulation. So what does this flow simulation do? I'll give you one case study. I'll explain with it. We all know heat exchangers, right? So I don't need to explain what is its function. So in heat exchanger, there is a exchange of temperatures. The cold fluid comes in, hot fluid comes in, and temperature is exchanged. So you can also simulate those things in SolidWorks, right? How the temperatures are affecting the model or the tubes, right? So I'll jump on to the case study. So this is my model. It is made up of various parts. This is my shell, right? External component. Then there are these tubes. There are these dividers inside it, inlets and outlets. Now we have seen SolidWorks simulation added. You can also switch on to flow simulation to check how the fluid, it may be air, liquid, gas, behaves when it enters the model or it enters any, for example, valves or pumps or example like heat exchanger, right? Okay, so over here, what I have done, I have created domains where my fluid will be flowing. For example, you can see this region, blue color region with the tubes. There, water is flowing with the temperature of 40 degrees Celsius, right? And velocity of 0.5 meters per second. Similarly, there is this next medium in which it is water, but it is at 2 degrees Celsius. From like this, it will go out from here with the velocity of 5 meters per second. Right? So these are my inputs. And then you can set a boundary condition like what is the inlet velocity, and this is connected to environmental pressure, right? And the conductivity of the outer surface area, and the second inlet velocity and environmental pressure, right? And then you can set up goals. If you want to measure the temperature at this area, you want to measure the temperature at different regions, you can calculate or find out that. So let me just show the plots. So this is my cut plot, right? So how the temperature distribution is taking place, you can check. Here the water with 2 degrees Celsius will be flowing, and from here water of 40 degrees Celsius will be flowing. So you can clearly see the temperature distribution is given here, right? And also you can create flow trajectories to it. So you can check how the fluid is flowing within the model. Right? Then let me just play. So it will highlight you how it is flowing. Again, coming back to my presentation. Yes, so this is my flow trajectory. So here there are two more examples. So the first one is one solar structure in which the flow is flowing around the object, and second one is my aeroplane or an aerodynamic shape. So in such examples also it is majorly used. Now let me go on to the second case study of solar panel. Right? Now we all know solar panels, so it is one of the renewable energies where we use, and for that we have to design structurally that the component is safe structurally. There should not be any failures. If the wind is flowing at certain meters per second, it should withstand those effects, right? Okay, so over here I am having the model which I have designed in SolidWorks. So there is structure and different ground planes I have created, and I have just patterned it, right? Again, coming back to the analysis. So let me just showcase you the input conditions what I have given. The air I have chosen as the fluid. Gases, it is air, and it is flowing at the velocity of 42 meters per second in this direction. You can check the arrow, right? So what if the wind is coming in this direction, whether the structure will take the load or not? So that thing you can do. So let me showcase the results. Here are the results. So you will see here what is the velocity coming up. Also you can probe the results if you require at any area. So we can see clearly the maximum velocity is coming at these two regions, right? Let me just hide this, hide all the probes, and showcase you the next set of results. What are the pressures coming up? Now the pressure will be coming up at the back side of the panels, right? Because of the wind force coming from the back end. So I have plotted the pressure plots also. So let me just hide the panels so we can see the results. Just hiding each and every panel. Yes. So this is the pressures plot what I have created. So the maximum pressures are coming up on these panels. So the uplift force will be occurring, right? And the minimum pressures and maximum pressure distribution you can check clearly here. Okay, and let me again just unhide this all panels for you. Right. Similarly, what if the wind speed changes every time? So we all know wind is not constant. It will be changing. I have used here 42 meters per second. But what if the wind speed changes? So you can carry out a what if analysis in which you can specify different speeds of wind. So I have taken 42, 29, 49, etc. You can take n number of speeds of wind and then check the result. What is the vertical upward force coming on each of the panels, normal force coming on the panel, etc. And from there you can specify that the wind loading capacity of this solar structure is, say for example, 50 meters per second. So beyond 50 meters per second it will not withstand, etc. So you can conclude like this, or else you can increase the rigidity or strength of the model, right? Now, one of the great advantages of flow simulation is you can directly export the result to simulation. So the output of flow simulation, you can take it as an input in structural simulation. You got my point? So once you create your structural analysis. So this is my structural analysis window, right? So I have taken one study, the study I have created, and from here you can import those results. Here, include fluid pressure effects from SolidWorks flow simulation. So you can take the CFD results and take those output results as an input in structural analysis. These are those results as an external load. So I have only given the gravity load here. So let me just show you. Right. So I've just taken gravity load in minus y direction, and these are the results. Whether the structural members would take the load or not. What is the stress coming up? What is the displacement because of the wind force? So let me just animate so that you will have better understanding of the results. Yes, I'll just change the angle. Right? So this is how the structure would behave when the wind is coming from the backside of the model. Right? So let me move forward. So we have checked the velocity plot. And you can create transient analysis also with respect to time. So I have done this for 1 second duration. So you can see how the velocity is changing with respect to time. Right? And this is the pressure plot, what we have seen. Yes, you can even do wind farm analysis. So I have just created the pattern of the structure and then I have done the analysis. Right? Once your structure is safe, then you can do the CFD of entire wind farm as well, like we are seeing here. And also we have seen structural analysis. We have used gravity load and taken CFD results as an input, and we have done the analysis. So these are the images of the same. Right? Stress, displacement, etc. Now, once everything is completed, you have so we have started with the 3D modeling, then we did fatigue analysis, structural analysis, CFD analysis. Your product is now safe. Then what we do? We can go ahead with the technical documentation. So we are also having one more thing which is called SolidWorks Composer. Right? So it is again one more add-in by which you can create manufacturing assembly instructions, installation instructions, how this product is going to be installed at the region, maintenance and repair guides, right? You can do all these things here. So I will just highlight you those things. So this is a very good software called Composer, in which you can create good installation or maintenance manuals, right, by defining different positions as I have created here, how the nuts and bolts are going to be assembled, right, how you can disassemble them, which channel will be assembled to which channel, and you will get the results in Word, Excel, or even in you can open in the web page also, right? So different technical documentations can be done, right? So you can specify first the bolt will be coming in, then the washer, and then the nut will be coming in, etc. Right? So solar mounting, system how you can make use of SolidWorks Composer to do the technical documentation. Now we have the documentation is also done. Now we have to do the high quality rendering for marketing and advertisement purposes. So for that, there is SolidWorks Visualize available, which is again SolidWorks software in which you can create stunning images for marketing purpose, for sales and marketing. So these are some of the examples which I have created using SolidWorks software. So these are all CAD models, and I have done the rendering of all these parts in SolidWorks Visualize. So you can see how clearly all the details are shown. Right? So these are all CAD models only. So advantages, so you can create photo quality images, interactive 3D content to bring your product to life. Also improve internal design engineering sales review to help make more educated final decisions. Deliver photorealistic imagery with content to marketing much earlier to help promote products. So before your product is manufactured, you can start marketing activity. Right. So once your modeling is done, analysis is done, all the technical documentation, rendering, everything is done, you can manufacture the product also. You can manufacture prototype of it to have the form and finish of the part. You can use future of manufacturing, that is 3D printing. So the last part of my presentation is 3D printing. You can manufacture the product as well. How SolidWorks will help in 3D printing, so that we will check here. So there are two procedures I have shown, without additive manufacturing and with additive manufacturing. So how it is different? So first one is simple. You do design, validation, then you do tooling design, then tooling validation, then manufacture, etc. But here, with additive manufacturing, you do design, validation, and just 3D print it. There is no need for tooling design, tooling manufacturing, etc., which is again a time-saving technique. Now, working towards the next generation of product, I will just highlight you how this 3D printing works. So this is one of the simple technique what I'm showing here. It is called FDM, right? In which the raw material comes in the wire form, it is melted, and then it is created by printing one layer above the other, and the table moves downward, and the height is adjusted, right? So I hope you all are aware of this simple 3D printing manufacturing process, right? So this is the one. Okay. Now, how SolidWorks helps you in 3D printing? So let me highlight that. I will jump on to the SolidWorks. Let me go back to my model. Yes. So I'm just opening the model from the assembly. So this is my crank, right? Yes. So I have given the material of 6061 T6 SS. So you can see how perfectly it is showing the color of the material as well, right? Yes. So I was talking about the 3D printing. So here is the option print 3D. So SolidWorks is having inbuilt database of various printers over here. It consists few of the renowned manufacturers of 3D printing machines like 3D platforms, 3D systems, etc. So you can select this from here. You're also having Envision Tech over here, Perfect Tree or Micro Plus, Extreme, Vida, etc. You can select from here, right? Or else, if the machine is not available, you can create a custom by selecting the bottom plane of the model, how your model will be printed. This is my bed volume. So you can insert here what is your bed volume, height, width, and length, whether your model can be printed in your bed volume. That thing also you can check from here, right? Or else you can say orient to fit. So SolidWorks will automatically decide which is the best position the part will be printed, right? Even you can scale it. So in the build volume, it will scale up the model and print accordingly by covering the whole area, right? Even you can have the option of infill. How much percentage should be solid, how much percentage should be air, etc. can be done here. Okay. So there are various options like show striation lines. It is the layer height. So if you reduce it, the layers will be increasing or decreasing as per convenience, etc. Even material, etc. Everything. Show preview slices. So it will show in the slices form. See. So options are various. You can make use of all this option to print your model. Right. So we have seen this. Now, what is the role of my company with engineering technique during this COVID-19 outbreak? So we manufactured various medical face shield in our office for various hospitals, medical staff, right? For security personnel, government officers, etc. So it is used to protect eyes, nose, and mouth. So we have printed this in-house. So this is the work in progress. I guess till now we have supplied thousands of face masks all over India, not only in Vadodara, from Delhi, Hyderabad, etc. So we have also received media coverage. So in few of the articles, our names were also published. Also, we have designed and printed door opener to avoid touching palm. Right? So in this outbreak, it is very important. You should not touch any object. So this is again one of the innovative thing what we have designed in SolidWorks and printed in-house, right? Also, we are active on various platforms, like you can tune into LinkedIn, Twitter, Facebook, Instagram to have the latest updates, what we are doing, right? Latest technologies, what we are using, etc. Yes, and some of the SolidWorks clients what are using in Gujarat region are listed above in this slide. So I like to say impact on product design. Without simulation, decision making is like this. So this is just a small video, you can have a look. If you don't use validation, so the decision making will be like this. Right? So this was one funny video. Finally, I would like to say learn and adopt quick ways to validate your design so that the products are manufactured just right. Now, I'd like to just conclude by a few of the education profile of engineering technique. Right? So we are also into the education sector in which you can check over here. We have it available all over the Gujarat, right? trainers. We also have all these things. Also, we support incubators and accelerator support. Like I create GTU, Innovation Council, Startup Weekend, etc. Now, one important thing I like to announce is every year Akruti is a competition which is done by Dassault Systems, in which we are also partners. It is a competition for all the graduates and all the people like you. So this year's competition, I like to launch themes. These four themes are open. Small is big, design, product for rural entrepreneurship, medical devices with innovation, and stop pollution at source. So the registrations will open soon. We will let you know when the registrations are open, so you can take advantage of this competition also. Yes, so these are the themes. So you can start preparing if you want to choose your themes and move ahead. And also, I like to say that RNGPIT College, you are having your own SolidWorks lab. International certified faculties are available in your college itself. Courses are implemented with various certifications, so you can make use of that. You have your 3D printing lab, right? So various placement drives are done at your college in SolidWorks career days. So you can even take the knowledge of SolidWorks, or you can enroll the in 3D printing certification course at your college also, right? So that's it. I'd like to thank HOD and all the faculties of the college for letting me have the presentation. And finally, social distancing, please maintain it. Personal hygiene, be vigilant and be optimistic, and stay safe, stay home until this outbreak is over there. Thank you. I'd like to know if there are any questions from your
Yes,
side.
sir. Sir, I'm displaying one question on screen. Right.
Okay.
Yeah. You can end sharing your screen so that. Yeah.
Yeah, yeah. Okay. I think I've ended the sharing, right?
Right, right.
Okay. So what about stress concentration? Yeah. So what about stress concentration when we optimize the geometry? Yeah, the stress concentration region will change. So in stress concentration, we are having an option where you can actually find out the stress singularity coming up on your product, right? So I'll just like to highlight you that thing as well. This is a very good question. So we are having the option of diagnostics. I'll just like to share my screen for a moment so that I can answer the question. Okay. So is my screen visible?
Yes, sir, it's visible.
Is my screen visible now?
Yes,
Yes,
yes.
yes.
Okay. So we are having this good tool first if you want to check the stress concentration. Like stress hotspot diagnostic tool is available, which will let you know if there are any stress concentrations or hotspots, right? As in this case, the hotspots are detected on all these edges, which are highlighted over here. See, and then it will tell you what is the current value and what should be the value to, for example, reduce it, right? Even you can run stress singularity diagnosis, and it will highlight you the edges where stress concentration is occurring. So on that region, you can work and go ahead with the analysis if any of them are occurring. Okay, I hope I have answered the question. So is there Any next question? Anytime
Sir,
you
I have
can.
one.
Yeah, please.
Sir, I have one question related to 3D printing.
Okay.
Sir, how much do we have to wait for metal 3D printer in our region?
In our region means in
Yes, sir.
Gujarat or India?
Yes, in Gujarat, in India, because
Uh,
they are too costly.
Yeah, actually, we at Engineering Technique have our tie-up with Markforge, which is a 3D printing manufacturer for metal, carbon fibers, etc. Right. So, if you have any queries regarding to metal 3D printing or
Yes.
composites like carbon fiber, etc., you can contact us directly.
Okay, sir.
Yeah.
Sir, I think, Nirav sir, we don't have more questions.
Okay, sir.
So I hand over to you, sir, Nirav sir.
Yes. Okay. Thank you, Gaurav sir. It was very informative session covering live case studies of bicycle crank, CFD of exchanger, and flow simulation of solar panel, as well as optimization using topology. And this webinar is useful how industries are using simulation tool to minimize cost of the product. Sir
Yes.
has thoroughly explained integration of 3D printer and SolidWorks modeling. Thank you, sir.
Yes. Welcome.
Now, I'm over to Dr. KB Rathod, sir, for the vote of thanks.
Okay, first of all, I would like to thank Gaurav Harane sir that he has given his valuable time for our students. Therefore, I would like to thank Gaurav Harane sir on the behalf of Mechanical Engineering Department of RNG PIT as well as from the whole RNG PIT family. Thank you very much, sir.
Welcome, sir.
Okay.
In future, if there are any queries, so you can directly come in contact with our company, or else you can directly call me. And thank you for giving us opportunity. I thank Mr. KB Rathod as well as Nirav Rathod. Thank you, and entire college. Yeah, thank you very much.
Okay.
Thank you, sir.
Yeah.
Okay.